Theorem: let V be a finite dimensional inner product space and let T be a self-adjoint linear operator on V. Then there is an orthonormal basis for V, each vector of which is characteristics vector for T. Proof: since T is a self-adjoint linear operator on a finite dimensional inner product space V, therefore T must have a characteristics value, and so T must have a characteristics vector. Let 0 not equal to alpha be a characteristics vector for T. Let alpha 1 equals to alpha upon norms of alpha, then alpha 1 is also a characteristics vector for T, and norms of alpha 1 equals to 1 if dimension of V equals to 1, then alpha 1 is a orthonormal basis for V, and alpha 1 is a characteristics vector for T. Thus the theorem is true for dimension V equals to 1. Now we proceed the induction on the dimension of V. Suppose the theorem is true for the inner product space of the dimension less than V, then we shall prove that it is true for V. Let W be the one-dimensional space of V spanned by the characteristics vector alpha 1 for T. Let alpha 1 be the characteristics vector corresponding to the characteristics value C. Then T of alpha 1 equals to C of alpha 1. If beta is any vector in W, then beta equals to K of alpha 1. For K is some scalar, we have T of beta equals to T of K alpha 1 equals to K T of alpha 1 equals to K C of alpha 1 equals to K C alpha 1. So T of beta belongs to W. Thus W is invariant under T. So W normal is a self invariant under T star, but T is a self adjoint, which implies T equals to T star. So W normal is invariant under T. If dimension of V equals to n, then dimension of W normal equals to dimension V minus dimension W equals to n minus 1. So W normal with the inner product form of V is an inner product space of the dimension 1 less than the dimension of the V. Let U be the linear operator induced by the T on W normal, that is U is the restriction of the T to the W normal, then U gamma equals to T gamma. For all values of gamma belongs to W normal, the restriction of the T star to the W normal will be the adjoint U star equals to U. Now U is a self-adjoint linear operator on W normal, because if gamma is any vector in W normal, then U star gamma equals to T star gamma equals to T gamma equals to U gamma. So U star equals to U. Thus U is a self-adjoint linear operator on W normal whose dimension is less than the dimension of V. Therefore, by the induction hypothesis, W normal has an orthonormal basis alpha 2 so on alpha n consisting of the characteristics vector for U. Suppose alpha I is the characteristics vector for u corresponding to the characteristics value ci, then u of alpha I equals to ci alpha I, which implies t of alpha I equals to ci alpha I. So alpha I is also a characteristics vector for of t. Thus alpha 2 so on alpha n are the characteristics vector or for t. Since v equals to w summing of w normal, so bit equals to alpha 1 alpha 2 and so on, alpha n is a orthonormal basis for v, each vector of which is a characteristics vector of t.